So up next we got unit 6, which is area under the curve or integration, but we're not there yet. So what is area under the curve? Well, like the name suggests, you're looking at the area under a curve, right? So if you have a function and it looks like this and it goes wah wah and it ends right here, you're looking for the combined area of everything under this curve, right? All of this down here. I mean that's basically what it is if you're being simple. One thing you have to know though is under the curve doesn't just mean like physically under it. It means in between your curve and the x-axis. So if, for example, you have a function that's down here and looks like this, under the curve means this part here because it's in between the curve and the y-axis. And if you have a function that like jumps around a bit and it's like up and down and up again and then down, your area under the curve is going to be all of this, all of this, all of this, and this part down here, right? It's anything in between your line and the x-axis regardless of where that is. So the first way that they show you how to find the area under the curve is by turning it into shapes. So for example, if you have this problem right here, it says the speed of a car is measured in miles per hour by f of x over 8 hours. How far did the car go in total? So on your y-axis, you have the speed in miles per hour. This is already a function measuring the rate of change. And on the bottom, we have hours, number of hours, right? So you have your line showing the speed and you have the time traveled. So how would you find the total distance traveled by this? That's when you look for area under the curve. Area is when you're looking for the total amount in a function. So to do this, if we're trying to shade in all of this area here and add it all up, how can we do that, right? We could use skills from geometry and make different shapes that we know how to find the area of. So we can turn this first part into a triangle. We can turn this next part here into a rectangle. And we can turn this one into a trapezoid or a triangle and then another rectangle, right? And then we just find the area of all of these because, you know, we already know how to. So this first part, we have a triangle that is 3 by 30. So if you know triangles is base times height over 2. So if we have 3 times 30 is going to be 90 over 2 is going to be 45. This rectangle here is 2 by 30. So this is going to have an area of 60. This rectangle down here is 4 by 30. So it's going to have an area of 120. And this triangle up here, it goes from 30 to 50 miles an hour. So it's 20 by 1, 2, 3, 20 by 3. Use this formula again with 20 and 3. You're going to end up with 30. So then to find the total area together, all you have to do is add them together. So you have 45 plus 60 plus 120 plus 30. And you're going to end up with a total area of 355. And you can't forget the unit. How far did the car go? It's measuring in miles. So 355 miles. And this is going to be your solution. So the basics for area under the curve, you want to divide your graph into shapes and then solve the area using geometry. And one last example, let's say we have this function here and we're trying to find, once again, the area under the curve or the total amount for this function. So again, just like before, we should divide this into different shapes. First thing I see is this big old rectangle right here. We could make this a trapezoid, but I just think that that's more difficult and kind of unnecessary. I also see a triangle right here, a triangle right here, and this is a semicircle up here. So just like before, we're going to find the area of each. This rectangle is 7.5 by 6. So 7.5 times 6 is 45. This triangle here is 2.5 by 6. 2.5 times 6 is 15. Half of that is 7.5 because it's a triangle. And this semicircle up here, the area of a circle is pi r squared. And since this is half of a circle, it's 1/2 pi r squared. So the radius in this case, the diameter is 2, right? So the radius would be 1. So we have 1/2 pi times 1, or pi over 2 is the area of our semicircle over 2. So down here we have another triangle, but this time it's underneath the axis. So what that means is that whatever it is, it's negative because you're subtracting it from the total because you have negative numbers down here. So our width is 2 and our height is -6. So the area of this is -6. Now in total, we just add all of these together. We're going to get 46.5 plus pi over 2. So that's it for finding the area under the curve when it gives you a graph that you just turn into shapes. This concept is pretty simple, but you don't really use it that much because you use calculus ways to find area under the curve, which we're about to go over. So we're moving on.